This next problem says how many joules of energy are released when 0.85 moles of water at 0 degrees Celsius freezes. So once again, we're already at the freezing point of water. So we don't need to use Q equals M times C times delta T. We don't need Q equals MC delta T because we don't need to have a temperature change. There is no temperature change. We're already at 0 degrees Celsius. So instead, we need to use Q equals M times delta H. And since we're doing freezing is when we go from a liquid to a solid. And whenever we have a solid-liquid transition, solid to liquid or liquid to solid, we use delta H of fusion. So, in this case, we need our delta H of fusion is on our formula sheet. Let's see, delta H of fusion for water is on our formula sheet. So it's 334 joules per gram. 334 joules per gram. So we need for our value of M to be in grams. Right now, it's not in grams, it's actually in moles. So we first, before we can use Q equals M times delta H, before we can substitute in that value of M, we need to convert it to grams. So right now we have 0.85 moles. We need to convert our moles into grams. So 0.85 moles of water, H2O. And so we just need to do a mole to gram conversion. So moles on bottom, grams on top. And we know that 1 mole of water is equal to some number of grams, and we can use a periodic table to add up the molar mass of water, or you might already know it to be 18 grams per mole, but let's go ahead and check that out just real quick. Hydrogen being about 1 gram per mole, and then oxygen being about 16 grams per mole. So H is approximately 1, oxygen is approximately 16. We have 1 oxygen and 2 hydrogens, so that gives us a total of 18 grams per mole. So then when we do 0.85 times 18, let's see, 0.85 times 18, I got 15.3 grams. 15.3 grams of H2O. Okay, so now that we have our M in grams right here, we can substitute that in and our units will cancel properly. So down here, I'm going to do delta A, or sorry, not delta, Q equals M, being mass, 15.3 grams, times our delta H of fusion, which is 334 joules per gram. So now when we look at this problem, our units are going to cancel properly. We have a grams in the numerator and grams in the denominator, so those cancel out. And we're just going to be left with joules, which is the unit that we want in the end, looking back at our problem. All that's left is to type this into our calculator. I already have 15.3 there, and I'm going to multiply it by 334. So I get Q equals 5110.2 joules. Now, just looking back at our problem for significant figures, I see that there's 2 and 0.85 moles, and then 0.0 also has 2 significant figures. So we'll round this to the first 2 places and look at that 1 to determine whether to round up or down. So we're going to put 5, 1, and then we'll fill in placeholder zeros in both the places before the decimal point. But those zeros are not significant because we are not going to put a decimal point. So 5100 joules is our final answer.